Hello guys, I'm Alvaro Viloria. I work at Groupon. I'm going to be talking here about our experience of how to productionalize machine learning with sparkling water and MLFlow. I'm a software engineer, so I am the guy who's been working here a lot with our team. So I'm the guy in the mod. I just take out of the mod to be here to talk with you guys. And this is what we're doing. We're trying to create a reliable machine learning models. And the mean reliable, we will think, oh yes, it's predicting what you expect it to predict. But it's a little bit more than that. It's understand the ecosystem of your model, understand everything related to your model, understand the hyperparameters, where the data comes from, understand features, any constraints or query apply all the data sets to produce the data that you apply to create your models. And that's all important when you want to reproduce the exact same model with serving production. Remember, when you're in production, you're making money or losing money at the same time. So you want to be very accurate at the moment of reproducing a model. So you may know Groupon. I hope so. And this is one of the things we're doing. And what is Groupon, for those who don't know, is an e-commerce marketplace when users meet our local merchants. How they meet them? Because local merchants use Groupon to offer deals. What type of deals? Restaurants, things to do, concerts sometimes, a lot of like massages, and there's services. There's a lot of stuff you can find in Groupon. I found that there's a lot of shoes also. So it's a very important marketplace right now. By the statistics, we're talking about top 6 rank in iOS. That's something, right? We're talking about like 12 billion into the business of the local merchants. That's making the local merchants a better place to be right now. So the question is, how do we incorporate machine learning into Groupon? So I resume this problem as like finding a needle in a haystack, finding the right deal to the right user. So if you have Groupon app and you like open right now Groupon app and you pick your neighbors, it's most likely you're not going to be seeing the same ranking, the same deals, because we try to you use machine learning to personalize the response. We try to make that response the most accurate for each customer. That is a big problem. The first problem we have is that from the moment we have the request to the moment we have the response, we only have 300 milliseconds. If we have 100 deals, that will be easy. We have more than 1 million deals. So how do you score 1 million deals? Do everything you have to apply, like business logic, decoration, all the stuff, to make a nice response to your customers. So we do apply machine learning. So we divide it into 2 elements. First, well, we have our database in Elasticsearch, which is very powerful. And we divide the model into 2 models. One very simple model and one more complex. Let's talk about the complex model first. So all our models are built using machine learning, using H2O, sparkling water, because the data we have is huge. So we need a Spark context to run it. In order to do that, and we want to use H2O, we use Spark plus H2O, hence sparkling water, to make these models possible. So batch scoring. Batch scoring, we're using very complex models, very complex features. Those are deal intrinsic. We're only thinking about the deal in this moment. We're not applying context. We're not applying personalization. We're thinking how and what is the quality of the deal, what makes that deal good. And we score it offline. And we put that information back again into the Elasticsearch cluster. So each deal, we have a score saying, this is the quality of this deal. Then the requests come, and we have a very small model. And it's like internal joke in our team. We talk about this is not a forest. Like we're not talking about hundreds of trees. We're talking about teeny tiny 15, 20 trees. So this is a garden. So this little garden is making the magic happen for Groupon. So we're talking about, we use the context, we use personalization, and we use deals information. And the most important thing, we combine the deal quality score offline model with the online model, and hence we produce a machine learned response. So it's been very interesting road. We have been here like more than a year to accomplish this. We do use Hadoop, we use MLFlow, is going to be talking later, Scala, Tableau for previous analysis, and Airflow to orchestrate each step in the pipeline of machine learning. So I'm going to go very quick in this one because I hope everybody knows the life cycle of the models here. But I do have to say the part that struggle the most and take our time and effort is to overcome the feature engineering. Data is important. It's the most important thing when you're talking about machine learning. If you don't have the proper data set, you're going to be having not a good model at the end. So we do invest a lot of time on making that data set appropriate for our training. We do some feature selections. If you try and use all your features, you're going to be expanding your feature vector, which will be affecting the latency of your model and the moment of the response. So you have to use the correct features and only those features when you're building your model. Remember, we only have 300 milliseconds. That's not a lot. Then you come to the part of model building, the tuning. You evaluate this model. You say, okay, this model is behaving okay. You have your metrics. You say, okay, we're working with AUC, so with over 80 AUC, we're doing okay. Can we continue? We're not kind of continue. You're going to be tuning your hyperparameters. This is the part which you also take a lot of times, and then you like have 100 models. You have to pick one to be a release model. And after everything that's checked green, you can serve the model. Now this has some problems. These problems is what I want to talk about you here. Okay, everybody's talking about having models in productions, but what does it mean? What does a model in production? So first, we're using H2O, but other teams and other companies that use one of the competition. Like you can use TensorFlow, you can use Spark ML, you can use whatever. We are using H2O because H2O makes it very easy to work with Elasticsearch. Big thank you to the modules. But then, when you have a team or you have an organization, then there's a lot of data scientists working there. You have to orchestrate, you have to like standardize things, but you don't want to standardize the way they can think and the tools they can work with. You want to standardize is the information what you are producing. Okay, so we have to handle the problem as there's going to be other guys trying to do machine learning with other tools. Reproducing results. So I wanted this to be like a plug and play. You have a model. This model is serving production. I don't want you to grab that model and put it back in the staging and see if it's okay. I want to grab the information that built the model, build it again, accurately, knowing that it's going to be producing the same exact model. We talk about versions of libraries. We're talking about features. We're talking about environments. We're talking about the exact dates you use for training, the exact schema you use. There's a lot of things you have to take in consideration here. Because the thing with machine learning, lifecycle development, is it's complex. You have too many knobs to turn every time you're doing machine learning. I believe everybody here suffered that problem. When you go to production and say, oh, now what can I do with this model? I can't remember which hyperparameter I put there. I want to know exactly what it has there. So that leads to another problem, tracking your models. So when you have your model and you have your problem, you have clear of the problem you want to solve, you start running and running and running models because this is experimentation. You have to like see which is the perfect intonation of everything. You tune everything up so you can maximize the best results you can do. So you do grid search, you use AutoML. Seeing here, you can use databases AI. There's too many things to do, but you want to track each of those models you're producing because that's knowledge. You don't want to lose that knowledge. Because at the moment when somebody's going to review your model and somebody's going to ask you, why are you saying that these features is important? Why are you saying this hyperparameter is important? Why are you saying that increasing the number of trees and decreasing the max depth actually increases the power of prediction of your model? You're going to come with your set of all experiments and you're going to say, this is how I did it. So the problem is, if you're doing Google Docs or whatever, it's going to be sometimes hard to like put everything in the same place, and it's going to be hard to put there each iteration you're doing, because sometimes you're running 100 models on one week. So this is going to be a great and big Google Docs. So how do you do it in an automatic way? That's one quick question. And then, of course, coming the part of deploying the model, how you deploy the artifacts, how you handle the artifacts, how you track your experiments. You want to know you're losing or you're making money. If you're making money, yay, you want to keep doing that thing. If you're losing money, what do you learn from this? Because you don't want to repeat it. And of course, last step is your model will decay. And sad to say that, it's a fact. Eventually, every model in production will decay. So how do you react to that? So we have something called model management model. It's called MQ. That's a fancy, nice name. We defined 4 use cases: reproducibility, management, governance, and evaluation. Reproducibility, I already talked about this kind of a lot. You want to be able to reproduce the exact same model. So you want to track everything, but you want to track in a smart way. Every time you like tracking a model, you want to put everything into a place like centralized. You don't want the data scientist like writing that directly. You want it to be automatic. You want that the moment these guys start creating a model, that model, everything related to the model is automatically being pushed to a place and organized way so you can use it and reuse it, and then the boss can come here and say, oh, my guys are working, and see what they're doing. And when the CEO asks your boss, hey, are we losing money, or why are you coming with this solution, he can show you, this is what I'm doing, this is what my team is doing, this is what I am doing. And so you can show all that very beautiful, tidy way. This is smart way to produce models. It's safe. Safe is equal to smart, in my opinion. So when you have this model and then you say, okay, I'm going to launch this model into production, it's going to be, hey, wait a second. The team is going to review it. Other elements of the organization is going to review it, because a model in production is money. We're talking about money here. So it's important. Every time you launch a model, it's money will be affecting. So you have to be clear which feature you're using. How do you do the feature engineering? Are you applying correctly the mathematics around it? There's a lot of things you have to take in consideration. The other element is the governance. It's tracking your experiments. The way to say it, I hope I don't put fear in your heart when saying GDPR, but GDPR is something that happens. You should put some regulations from law, and you have to apply those. So you have some. Let's say one day they come with a new regulation. They say you cannot use any location whatsoever in any elements of your organization. How you will freak, I will freak. So one way to avoid it is you go to your model management model, MQ, and you go there and you start picking every model you have in production, and you see the features you have there. And you say, this guy has a location, this guy has a location, this guy has locations. We have to shut down those models, retrain them, launch them again without that feature. What if we don't have it? What if we come with a regulation that puts something mandatory to us, and we don't have the means to evaluate sharply and quickly each model we have launched in production? That is the harsh question we have to ask right now. And also, how do we evaluate decay? So one of the elements is key elements for me is when I train a model, I apply some constraints of the data set, I apply some queries. I want those exact same constraints and any assumptions I did apply in the information that's streaming into this model in the moment get it evaluated, because I want to have a nice evaluation. Because if not, I could be comparing apples to oranges, and then my decay could be rising false alarm, or worse, I will be suffering decay but not knowing. So I have to know exactly how this model was trained, the data was trained, how was consumed the data, so I can apply the same concept at the moment of evaluation. Okay. MLFlow comes here to help us. The first thing I love of it is it's open source. It's an end-to-end machine learning platform. It's backed up of something very big called Databricks, Spark, I have to say there. And the thing I use the most, and the most important thing, is it's accessible through REST APIs. And provides API for Java, Scala, Python. I actually use it very much in the way I introduce these APIs in the moment I'm doing scripts, in the moment I'm doing the model. So in the pipeline, each element of the pipeline, I just use the REST API, so I can communicate with MLFlow in an easy way. It's very simple. And MLFlow actually provides free products that answer questions I will just open. So tracking is the one we are using the most right now. So you track everything you can do. You can track parameters. You can track any metrics. You can track results. Then you can wrap these models into projects, and you can use these wrappers to reproduce exact same models. And then you have models as the last product of Databricks that wrap this model and push it around into the deployment cycle. So this is how we did it. So we have the raw data. We do apply the queries, and we separate the training and the test data set. That's something that most of we guys do. And then we come with part of the model exploration. We have the training, the tuning, and experimentation. We have Tableau here to help us to see how the model is behaving. We have sparkling water. But each model we produce in this step is logged into MLFlow. Each model. There's no model I train that's not there. And we publish this model if it's okay, and we start doing the evaluation of the model, and we use Kibana just to see how the model is behaving. So I'm kind of running out of time. I have a quick demo here. Can you still see the screen? Yeah. Okay, maximize this. Oh, sorry, I can't see here now. So I hope you are familiar with H2O flow, which seems to not working right now. I have a backup here. So this is a model I trained. This is, I believe, it's a 100 trees. Yes, this is a 100 trees. You can see everything is okay. You can see the AUC. You can see the feature importance. Okay, but what happens if I close this? What happens if I close MLFlow flow UI of H2O? I lose this information. I have the model. The model is stored in someplace, but then I have to load it again and do all the stuff. What do I do? I present you MLFlow. I did several runs. This is a several runs. This is tracking all the hyperparameters, which is kind of unreadable right now. So I'm gonna just put the ones I'm interested. So I'm gonna check algorithm and trees, and let's say max depth. And let's choose training AUC, I believe that's the word, and test AUC. Let's see. Yeah, those were the guys. So actually, I can check all my models I train. I train power of like a 5, 10, 15, 20 to 100 trees. And I just want to check how the power of training you see and test you see increases or decreases. So I can see that actually after 20 trees, there's no improvements. But what if I want to compare them? I can compare them one-on-one. I can see everything that get logged here. That now I want to see, okay, what if I put here entries, and I want to check how was the test that you see over it. So I can start seeing that actually in 20 trees, it get flatted, the area under the curve. So over the hidden part of the data set. So we actually can see that 25 tree will be a tree I will use in maybe in production with these settings. But let's say, how was this model? So this model will be the 20 trees. Yes, it was this tree. So this tree was a GVM, and all this information is accessible through a REST API. And actually, Scala API, Python API, R API, you working in Scala, a guy working in R can check the same information. If you're not working with any of this, you can only use a REST API and you can use it. Or my boss that is not coding, he can go to this MLFlow page and can see it and say, oh man, this guy is working and this is the element here, and he can come with all his knowledge and tell us, why are you using this feature? You should remove this feature. And then you go and have a better prediction. So I want to show you guys the importance of us as a team when we introduce MLFlow. MLFlow helps us go to the next level on building models. It helps us to do reliable, safe models. There's other tools similar to MLFlow. MLFlow was the one who suited us the best. But I invite you, in the moment you're creating models for production, please take consideration that you have to track everything you have to avoid future moments of running and trying to see emails and stuff like that. This is very simple, very fast. So this is it. Thank you very much.
Thanks, Alvaro. All right, we have time for one question if there's any. None. Okay, we're good. Thank you.
There's a question over there?
Go ahead. What did the integration look like between H2O and MLFlow?
It was very simple. I have it actually in code. I wish I could show it the code right now, but I cannot. I'm working on making open source. But the integration was, I have my H2O manager, which I did a wrapper of H2O using H2O APIs. And I have my MLFlow manager. And I launch everything in scripts. So you can see here everything I run. I actually running it through a scripts, which has H2O plus MLFlow running. So it's just a line of code. I initially shade the MLFlow environment, and I say, okay, I'm gonna start a run, give me a run ID, and then I start working with my model, and then I say, oh, I want to track these hyperparameters. I say, MLFlow, I want to track from this model with this run ID, these hyperparameters. I want to track this, and now these are parameters. Now I want to track a metric, like three types, three things you can track. You can track parameters, you can track metadata, and you can track metrics. Those metrics is like the results of your AUC. So you can say, oh, now I have the model score this data set, and that result, I want the AUC, and I want to track it with this run ID in this place. It was very simple.
Like so is this more of a batch export, or was it webhook, more webhook based?
Can you repeat the question, please?
Yeah, was that more of a batch export, a triggered batch export, or?
Yeah, everything was triggered. Everything I launched in batch. I actually, I'm working right now in grabbing the model, Pollo itself, extracting all the information from it, because the Pollo has that information. So you can put that information directly. So I trying kind of like from the flow, I want to explode that Pollo and make it directly into MLFlow.
Thanks, guys.
Thank you.
All right.